Today we are going to be talking about something called the composition of functions. And what that means is that we're going to be plugging in one function into another function to get a whole new function, which is made up of the two composed together. And that's why they call it a composition. So the composition of functions, the notation can look like this: G with this little open circle F, or GOF, or written in this notation where it might be a little easier to see what is going on. Because if I were to write g of 3, we all know that means take 3 and plug it in for x in my equation, or my g function. But if I see g and then this, that means I'm going to take my function, my whole f function, f of x, and plug it into x in g. It's kind of like how when we solved using substitution, when we had one equation that said y equals this or x equals whatever, we took that whole x equation or that whole equation and plugged it into the other one. So it is kind of the same idea here. And the way we read this is we read it from the left or the outside in. So we say g of f of x. Like if we were just talking about this part, we would say f of x. But now that is inside of g, so we say g of f of x. In a mapping diagram, this is what it would look like. You would plug in x for f of x, and then that result you would then plug into g of x. So if we look at some examples down here, you will see what I mean by that. So this one, f of g of negative 3. So we're going to start on the inside and find out what g of negative 3 is, and then plug that in for f of x. So g of negative 3 is equal to negative 3 squared minus 1, because here's g of x up here, x squared minus 1. Well, negative 3 means you plug in negative 3. For x, negative 3 squared minus 1 is 8. So now I'm going to take that 8, because g of negative 3 is equal to 8. I'm going to take that and plug it in for x in f of x. So f of 8 equals 3 times 8 minus 4, which is going to be 20. Now for letter B, it's slightly different because we're not plugging in a value for x. What we're going to do is we're going to take g of x, this whole equation, and plug it in for the x part of f of x. So I start by rewriting f of x, but instead of writing x, so 3, but instead of writing x, I'm going to write in g of x, which is x squared minus 1. And people will sometimes forget to write the rest of my f of x equation. You have minus 4. Make sure you have that minus 4. So I rewrote this 3x minus 4, but instead of writing x, I wrote what my g equation was, the whole thing, because it says g of x on the inside. So when I distribute, I get 3x squared minus 3 minus 4, which is equal to 3x squared minus 7. And that's my answer. Now, the next one has us going in reverse. It's g of f of x. So I'm going to start by rewriting g. G is x squared minus 1, but instead of writing x, I'm going to write f of x. So this is going to be 3x minus 4 squared. 3x minus 4 squared. And then g of x also has that minus 1. Remember, we need to write this out as 3x minus 4 times 3x minus 4. And then we got to FOIL that. And that's going to be 9x squared minus 12x minus 12x plus 16 minus 1. We get 9x squared minus 24x plus 15. And that would be our simplified answer, and our composed function. Now I'm going to do the next one down here, the next set, and then I'll have you try these. So g of f of 5, I need to find out what f of 5 is first. F of 5 is going to be 2 times 5 minus 8. 2 times 5 is 10, minus 8 is 2. So now I'm going to take that 2 and plug it in for g of x. So each x is going to get replaced by 2. So I'm really going to find g of 2. We have 2 squared minus 2 times 2 plus 6. So g of 2 is going to be 4 minus 4 plus 6, or just 6. So if we have a number, our answer is going to be a value. But if it's just g of x, or f of x that we're plugging in, then our answer is going to have x in it. So here, f of g of x, I'm going to take this whole thing, g of x, and plug it in for x in my f equation. So it's going to be 2, but instead of x, we're going to write x squared minus 2x plus 6. And then we still have that minus 8 from the f equation right here. Distribute 2x squared minus 4x plus 12 minus 8, which then simplifies to 2x squared minus 4x plus 4. And that would be our composed function. Lastly, we're going to go in reverse again. What this means is we're going to take my f of x and plug it into both x's. Like how in the first one, we took 5 and plugged it in for, we took 2 and plugged it in for both x's. So our equation is going to be x squared, but x is now going to be 2x minus 8. So we're going to have 2x minus 8 squared minus 2x, but again, x is 2x minus 8, and then plus 6. We're going to have to multiply this out. Right, when we distribute here, we're going to get 4x squared, or for that FOIL, minus 16x minus 16x plus 64. And then distribute this, minus 4x plus 16 plus 6. And now we can combine like terms. We're going to have 4x squared minus 36x plus 86. And that is my composed function. Now, down here it says our f of g of x and g of x the same thing. We looked at 2 examples now where it's not. Look at B and C. It is not the same. The final answer is not the same for these. So the answer is no. All right, I want you to go ahead and try this real quick down here. Pause the video, give it a try, and once you're done, unpause it and see what if you got the same answer that I did. All right, so here are your answers. Hopefully you got these answers. If not, you can ask me about them the next day, or rewind and watch the previous stuff and see where you messed up. Now, there are some stores that give you percentage off coupons and some are dollar off coupons. And sometimes they'll let you use both. Other times they make you pick one or the other, and you have to figure out mathematically which one is better. When you can use both, we're going to figure out, is it better to use a 30% off coupon first and then a 100% off coupon, or do we want to do reverse? Do we want to take $100 off and then use your 30% coupon? So let X be the cost of the item. And so that means 30% off means you're paying 70% of the price. So that's going to be 0.7x. So whatever the cost of the item is, we're only paying 70% of it since we're getting 30% off. Now, if I get $100 off, my equation is going to be x minus 100. Because if the item costs $200 and I get $100 off, or $300 and I get $100 off, it'll be $200. So we're going to show the math and see which one is better first. Cut. So we're going to do the math and see which one is better. Before we do so, just write down a quick prediction on which one you will think will be better. So down here, we're going to do the algebra view, and then we're going to do a real-life example down here. So algebraically, $100 first and then 30% off. So what that means is I'm going to do f of g of x because I'm doing g of x first, which was x minus 100, and then plugging it in for f of x. So my f of x is 0.7x, but x is now x minus 100. And when I distribute this, I get 0.7. I get 0.7x minus 0.7 times 100 is 70. Let me write this a little bit neater. So if I'm using the $100 coupon first and then 30% off, I would plug in the cost of the item for x, multiply that by 0.7, and then subtract 70. Now, if we do the 30% off first and then the 100, this is going to be g of f of x because I'm doing f of x, or the 30% off, first. So if we plug that in, I'm going to write my g of x equation, which is x. X is now 0.7x minus 100. So you can see here that when we compare the two, using the 30% off first actually makes the price go down by more. It goes down by $100 as opposed to $70. So we want to use a 30% coupon first. What I want you to do down here is plug in $500 for x in our equations up here. So 0.7 times 500 minus 70, and then 0.7 times 500 minus 100. And we can type those into our calculator. And for this one on the left, I get $280. And we should expect to get a value $30 lower for the one over here. So 0.7 times 500 minus 100, and that's $250. So by using the 30% off first, I'm saving $30 off of my purchase. So hopefully this is a good real-life example of the composition of functions. Thank you for watching. Make sure to like the video and subscribe.